Yep.
Okay, hello everyone. So my name is David Praise again. So today what we will be working on is so last week from last week tutorial we seen like regression algorithms. So we've seen like linear regression, and we've also seen decision trees and random forest regressions. So that's like one part of like also like make that's like one part of machine learning. So another part again that we'll also see that's like one part of like different problems in data science. Another part also is also classification. And today what we'll be doing, we'll be looking into different types of algorithms such as logistic regression and also a random forest classifier. So today, what we're gonna do is like based on this today's tutorial, we're gonna be like I found a really great problem over here. It sounds really interesting. I was like, why not share with you guys? So the main goal is like the loan prediction problem. So over here we have like the question that was asked or like was like a company wants to automate the loan eligibility process, so it's like real time based on customers' details provided while filling the online application form. So these details contain gender, the marital status, education, the number of dependents, income, the loan amount, credit history, and also other details over here, like the property area and the loan status. So basically, to automate this process, they have given a problem at identifying the customer segments that are eligible for the loan amount so that they can specifically target these customers. And here are like, and here they have like provided a special partial data set. So over here, it's like a Kaggle competition over here that I found and I decided to like share it with you guys. So if you can see my screen, which I believe you can, you see like the loan prediction problem data set. So over here we have like the data set provided for us with like a train and also the test sets. We have like 367 unique values, the male, different type of genders. So we have male and female. We have the married status, so true that they're married or not, the dependents. We also have like their education, the self-employed, and also different other categories to take in account into. So now for today's data set, where I'm gonna like walk you through some like feature engineering a bit. Then later on, we'll talk about these two algorithms on the brief highlight level so that you could get the idea about what they actually do. Then then we will make predictions with them. So before I continue, just confirm that you can see my screen.
Yep.
Okay.
Yeah.
Perfect. All right. So let's get started. So first of all, we want to start by with like our necessary imports, NumPy as NP, and also want to import pandas, Speedy. Let's wait for that. Once that is done, okay. So great, that is completed. So the next thing that we need to get like this data set. So you could either download it from the website from this particular link, or I've also uploaded it on my GitHub repository, github.com/database and it's loan prediction over here. So we got like the loan prediction test set and also the train. But we're interested in our training. You can see it here, training. And what we do is that we get the raw, take that. Now I'm gonna paste the link over here. So I will URL link. So we could say like, our train data link. The next thing we could do is like we could read this, this data CSV file using pd.read CSV, and we could specify the train data link, and the header should be like the first column. So over here, if you check over here, you can see our header should be like this column over here. All right, let's continue. So once we import it, now we can check, like you get a glimpse of our data set by using the head command. So basically to make sure that everything is working. So now we can continue like with further like to explore more on our data set. So we want to explore the data set by starting to use, like, if you're familiar with the, I guess, like you could start by checking like the shape, that's like you need to get around it and see what exactly you have. So data set the shape. You can see that we have like 6,114 samples and 13 features. We could also use like the describe function, describe. So basically you want to get like the numerical details. So these are all like our numerical values over here, and these are like details about it. So we have like applicant's income, the co-applicant's income, the loan amount, the loan amount term, also the credit history. And we could also use something like, to get more information about our data set, we could use the .info. So basically this is like a function that we're calling to get information. So over here we could see that we have like 114. So if you check like the size, it's 614 samples. And if you look over here, we have 614. We have 601, 611. You can see that these numbers, most of these numbers don't add up to the total amount of samples. So you can see that they're like missing values. You could also do something like train.data.is null. So we can check like the null values and all the non-values, and we sum them up. So you see that we have like 13 missing values in the gender column, 15 in dependents, 32 in self-employed, 22 in loan amount terms, 14, credit history, 50. And this gives us like a good idea of like, okay, of like the next step, what we need to do next. So basically what we need to do next is find a way to impute these missing values. So basically replace these non-values, which are like not a number, into something else. And what, not just something else, but into something that is related to each like the column. So for that example, our gender column, we could either replace it with either male or female, the marriage status, either yes or no, if they're married or not, the education history, if they're like graduates or not graduates. And that's what we do. So now let's start by doing something with data cleaning and doing like filling all those missing values. So data cleaning and filling missing values. Okay. Right. So we could start by like importing like the matplotlib for like visualization. Import plots because we're gonna be making like some visualizations to see something. As PLT, matplotlib, inline, and also import Seaborn. Also incredible visualization too. As SNS, then SNS 7 to activate it. And so now let's like start by, let's go like in, let's start by first our gender, by taking care of this gender column. So one way that you could do this is like, for example, to check like the gender dot train data, and to check like gender dot value count. So you can see that in our mill, we have like around 489 mills and 112 PDOs that applied for like a loan. So basically now it gives like a sense, since we have like more mills that applied for like this specific loan to the bank, what we could do is like replace those missing values with our uh, most occurring samples and most occurring like category. So it's the mill in our case, and to get like the index for this specific one, what we just need to do is like this part, then dot index of 0. And basically, we get like male. If we want the female, that's like the second index, and that's what we need. But now what we need is like the male. So basically, what I could do right now is like just to put this in a variable, so gender counts, and what's like the highest, let's say, gender count. It's gonna be actually this. So male over, and we could also print out what we have. Make sure you like always print out everything, just to get an idea, to make sure you're not going off track or you're not doing something, doing typing like incorrect commands, and you're getting like what we actually need. Basically, this is what we need. So now what we could do next is like we define like our impute function. So we could like call it impute gender. So basically the feature, that's like the feature what we want to impute. And over here we have like replace value over here. And have like, then we just do like feature fill non-values with. So since what we're going to be passing over here is a string, so this is going to be like a string, you need to convert it into a string, like the code type capstan, and our replace value over here. Replace value should be good. And the replace over here. Actually, the value that we want to replace. So basically, this feature and fill the non-values with this replace over here. And we call it something like in place equals true. And this like what this means, like it basically returns nothing. So basically what it does is just updates our data frame, specifically that feature column. Okay, so now we could call the function over here. So we could like impute gender, and we get like train data of our gender. And also we have like, what's like the highest gender count. And once we run this, but now, so just to get an idea, so basically what we're going to be doing is like, we're going to have like, we could make, okay, we'll see this later. I will talk more about it. And so once we impute the gender, then we can check, we call this, we check if everything is done correctly. So over here, you see gender is 0. And before replacing these values, we had like 13 over here. And if we like check the value count, see like, okay, definitely it has actually increased a lot. So now we have like 502 mills, and previously we had 489. So that gives us a sense that, okay, something actually changed. So just to comment this out, so this is actually agenda. I'm going to do the same thing for our next one, which is going to be in our case the married. So married. And also one thing you could also do, like if you want to make like a report out of this, it's also very useful to like make visualizations. So basically instead of this, we could also put this since we have a actually, yeah, so like this to make like visualizations out of it. So you could have something like this plot actually this value. We can reassign it actually. So once we've done the imputing, now we can reassign gender count is equals to this new value. And we can make a plot. And what kind of plot? We make a plot. And perfect. And we can go around modifying it here. So we have plt dot y label. So on our y axis we have frequency. Plt dot x label. We have gender. And plt dot give like a title, let's say gender. And look how it looks like. It's beautiful. So now we could do the same thing for like the married. So now we have like, you know, train data, married, value counts over here. So you can see that around 398 people are married and 213 are not married. So we could give it like a marital status count. And we want to get like the most current one. So we have like what's the highest marital status count. Basically, that's going to be our marital status count, the index of our first column. And we print that out. Status count. And the next one. And the highest. And copy this. Run that, and that's exactly what we need. And now we could go ahead like impute in these values. So we could find a function over here, compute our marital status. So we've got our feature and also the replace value. So we'll feature the field name values with our replace value, and in place true. Once we call that function, should mark the status. So feature train data of married, and we want to replace it with this value over here with the highest marriage status count. Oh, actually, once we find that, we're gonna do the same thing over here. And now once we check, like, example, this value over here, see that now we don't have like any missing value in our married column. So we could do the same thing over here and assign it. So basically our marital status count. Now this new value. And we can do the same thing by making a bar plot out of this. And of course, first, let's print it out. Basically, if you sum these numbers now, definitely add up to 614. And we can make a bar plot out of this. And just change this to the married X label. And frequency, and over here like value. Actually, there was a mistake over here. So we just have to rerun this from the top. No mistake. Always to check and print out everything to make sure you're doing the right thing. Okay, that looks good. Let's make a bar plot out of it. And it looks perfect. The married or not. Any questions? Right, it's not. So now let's move on to our next value. We have like the dependence. Here. So now we can do pretty much we're just gonna be doing like, the same thing that we've done over here over and over again. So in order to save time and also explain those algorithms to see also how they work, I'm gonna repeat the process. Now instead of marital status, we have our like dependence count. And what's like the highest count. And also we have to change this variable over here. Dependence. Over here. Okay. Run it. And bang. That's what we need. And the most occurring one is this first one over here. So now all we need to do is like impute dependence. And if you're not sure what dependents are, you just go all the way over here to the number of dependents. To continue our process. So since these values are also string, so we need to do the same thing over there. That's the string, that's correct. And over here, we need to replace it with dependents. And this married to status count has to be replaced with the highest dependence count. And we need to change the function that we call. And once we run this, and now we shouldn't have any dependents. That's good. And the next thing we can do is also to print out this value count to see if anything has actually changed. See over here, the top value over here has increased. So before we had 345, now we have 360. So we can assign that to this variable, so like dependence count. It's now equal to this. And finally, we can make like a bar plot out of this. So like dependence. Dependence. Okay, that's the correct spelling. So we have like dependence. Make a plot. Empty. That's what we need. So we could also check like the next one over here. In our case, it's the self-employed. So basically, it's going to be most of the time repeating the same thing we've done there. So in the same time, I'm just going to reuse the code and replace it with these values. Like this one, let's replace everything. So we have self-employed count. So we have self-employed. We can increase that. And the highest self-employed count print that out. Okay. So this means like most of them are either they're not graduates or not, either they're self-employed or not. So you can also have a look at what these values are by checking unique. Yeah. We either have yes, they're self-employed or not, and also NaN values over here. And what we need to do is that we need to get rid of this NaN value because it's pretty much like an outlier in our case. So impute self-employed. I'm going to call this function over, and in our case, we're going to have here self-employed, and replace with the highest self-employed count. So that's no in our case. And to run that, with self-employed, yeah, call this function, and we can check the counts and print it out. And you can see like the difference over here. So basically, the amount of counts and no has increased to 532, and previously it was 500. And now we could also make like a prop out of this. So you can name the title whatever you want to. And so that once that's done, we could also now we need to go to our next value and see that this process is a bit tedious. Imagine if you have working with millions of features. So basically that's like the most stressful part. So now we need to take care of the loan amount. So we're just gonna make one loan amount. Take these values over here. And actually the dependence count, that's actually the self-employed count. And self-employed count. We need to rerun the process. Okay, so what you need, dependence count, self-employed, the values, we assigned it, make a bar plot, perfect. I'm gonna repeat the same thing over here. The loan amount, including copy those cells. Select them, copy, paste them. I'm just gonna copy paste them open. Need it. So we have like the loan amount count, and over here we need to switch it with the loan amount. And also it's good to also get an idea of what exactly this loan amount is. So you can check unique. We have like different unique values in the amount they actually wanted. And also we also have NaN values over here. So there are different ways on how you could like tackle this problem. You could we could do is either like replace this loan amount. One way is like to replace this with like the most occurring one, or with the median, or with the mean, or like different ways. And you have to see like what works best, or according to what the company wants actually. the loan amount, the highest loan amount. And once we run that, basically the highest loan that was taken was actually 120. So impute the loan amount. There, loan amount. Place with the highest loan amount. And that the loan amount count. Place this value also. So basically, once we've done once we remove those non-values, and we need to reassign it to this variable, so to overwrite what we had previously over here. And so now I want to make like a basically not a bar plot, because a bar plot won't actually make sense out of this. So we can use it. But what we can use is actually like a function called describe. That's one way. So you see, like, the count, the mean value is 3, standard deviation is 3, so it's very like related. Mean value is 1, maximum 22 over here. Okay, and actually, I think we have like a misunderstanding over here. We shouldn't actually replace these values over here. So one way that we could do this, I'm just going to script this part out. So we got like the loan amount, so our train data, loan amount, describe. We need to run everything again. So run all. Yep. And right now, so basically we could see our median value over here is 128, and the mean value is 146. The maximum is like 700 actually, and the mean is like 9. So this is actually the correct way we want to do it. So we want to replace it. Let's say you could pick like the median value, or you could pick the mean value. Depends on which case, also what works best for you, as I said. So basically the loan amount, the median is basically this over here, median value. So we can take a look at the median value over here, and you can see it's 128. And what we're going to do basically is we'll have the there. So impute the loan amount, we'll get the feature and also the replace value. So we got the feature dot fill those non-values. In our case, this is an integer, so we're not going to typecast it into a string. So we got like the replace value, and in place equals true. So once we call this function now, and we pass in like, let's say, passing train data and the loan amount. So what are we going to replace it with? We're going to replace those values with the loan amount median. And now, once you check this describe column, there should be a change over here. So now we could see that the previous count we had like 596, and this is 614. The mean value is 145, and the median is like 128. And here we have like the mean value is 146, and the median is 128. So it's not like much has changed, just a little. Okay, so Now we could also call this we have over here. Let's find it. Okay, just type it out. Or train data is null. Sum. Here. That's taken out. Now we need to take care of like the loan amount term and also finally our credit history. Okay, so we can easily do that. Loan amount term. You could say like, you know, loan whole amount term count. Basically train data loan amount term value count. Yeah, so it's a good thing to see. Actually, this is check the unique values. Makes sense. Okay, so you have like 360, 120, 120, 180, 60 days over here. So loan amount term, the terms of loans in months. Okay, that's also a good thing to know. And we're going to replace it with basically the most current one. And over here we have like what's pretty much the highest loan amount count. Is loan amount count index, first value, and compare it out. This out also. That looks good. So now we could define like impute function that basically takes care of those missing values. So loan amount count, the feature, and also our replace value. And we have like a feature, fill those non-values with actually. So in our case, whatever here, it's an integer. So careful not to cast that. Place value and in place. I want to call this function over here. So for string data of loan amount term, and our replace value will be actually this highest loan amount term. Look at that. And once we also check, like we make like to see if that has been taken care of. So train data loan amount term. We've got our dot. What's it again? Is null. Yeah, so basically we don't have any non-values over there. The whole thing. Okay, that basically there. That's what we need. And finally, actually, our credit history. So we're almost close again to credit history. Check more details on that. So the credit history means like the guidelines. So to get more further information about that, you check train data or train history. And, so yeah, basically by looking at this, 1 means like yes, and 0 means like no, and also we have non-values, and we also need to take care of those non-values that we have. So basically we could have some, we could start by saying like history count. It's going to be this over here. We have here dot value counts, and it's pretty much the highest. The history count. The credit history count is going to be equals to the highest credit history count is going to be equals to credit history dot index, the first one. You can print that out to make sure that that's what exactly we need. And Jupyter Notebook is a very good tool for debugging, so I recommend you use it. And once you're gonna write code to like for production, then you should stick to like an editor, to your favorite editor. It's not bad. And over here, that's what we need. So now we need to define our impute function to impute credit history. So we have like a feature and the read place value. And we have a feature dot fill those non-values over there with our replace value. Since we're going to be working with integers, so replace value and in place is equal to true. Once we call this function on our train data credit history, and what's our replace value? It's our highest credit count. We call that. And now you could do the same thing like for train data is null, and the sum of all the. Pretty much now, with looking at this, we've done a good job by moving all those non-values. That's like first step that we should always take. And also, if you want to make a visualization of this, then what you need to do next is basically like here, so we have credit history count is going to be equals to history value count. Print that out. Definitely get a different value. And to make a plot out of that, just plot and what kind of plot we want. Bar plot, plt.x label, x-axis, say credit history, and plt.y label, so frequency. And we'll just check sure we haven't missed anything here. And yeah, that's it. No. So basically now we can, next thing we could do is like, so basically after cleaning, so this is like we check our results after cleaning. And so we have like train data head. You can see what we've done. And also once we check, like for example, train data.info, see that we have like all these values 640, 640, and they are not null at all. So now we want to make predictions using these like algorithms. The first thing that you should be careful about is that you should avoid fitting like these string values into like any of your models, because these models in scikit-learn, they don't work well when you pass like strings to them. So what you need to do is to somehow encode these strings, these categorical these categorical labels, these ones over here, the categorical values of them. So basically you could say, like for example, for the male, you could assign like to replace them with something else. So for example, say male could be like represented as 1, and females could actually be represented as 0 over there. And also the status, same thing for married, for the education, whatever one has like labels. Yeah, also the property area, and also the loan status. And we need to take care of that. There are ways on how to take care of it. Scikit-learn does actually provide you with some libraries. You could check it, it's called label encoders. You could also check that out. And I'm also going to show you like a way on how to actually do them, without using those what like Cyclone provides you. So basically, what we're gonna do is like encode features and labels. So we can start by like our train data, gender, and let's check like what's the unique value. So you have male and female, and you could say like train data gender, and it's going to be equals to this. And what we're going to do is like what we're going to do is to map our male to 1 and female to 0. Once we run this, check the unique value again, just make sure everything's correct. Yeah, voila. So instead of male and female, now we have like 1s and 0s. And so this is for like our gender. And the next thing we actually need to do it for is the married. So let's dive into that. Now we use this part again. Put it over here. But married. So either no or yes. So if they're married, yes, replace it to 1, and if they're not married, replace that to 0. And also change that. Over here. Do the mapping, check it, and married, no, it's now 0, and yes, it's now actually 1. So next we also need to do it for the the dependence. Let's see, actually dependence, yeah, it's an object. So why I said yes, because if you look over here, the data type, it's an object. Just copy this part and paste it over here. So we've got dependence. Dependence. Okay. So now we need to like do the mapping of all these values over here, convert them into an integer or float, whatever your preference is. So basically we have like 0 over there, should be like map it to 0, 1, map it to 1, 2, map it to 2, and 3, you could map it like 3, 3 plus. And that. And yeah, that's what we need. So now what's the next one? Let's check like education. So we've got either they're graduates or not. We use this code again. And graduate or not graduate. Do the replacement and map the graduate to 1 and not graduate to 0. And that. And that. The graduate values are being placed for 1 and not graduates are 0. And what's the next one in our case? So we've got like the self-employed. Yep. So see that it's an object over there. So we need to do the same thing for self-employed. And switch this to education. Employed. Right there. And if they are, yes, and if they are not, Yeah, and that checking values, and now they've been replaced. So that's exactly what we want. And what's the next one in our case? It should be the property area to group in a rural. Do the replacement. T area. T area. Unique values of urban, rural, and also this one, semi-urban. So put the areas. So we got like urban, make urban 2. But the next one, the rural, 1, and semi-urban 0 on that. And that's exactly what we need. And finally, it's actually our loan status. That's like our targets in our case, what we are actually trying to predict. Loan status, that they're approved or not. So we got the statistics. So Y means like yes, and translates to like no. So if it's Y, 1, and if it's N, 0. And that should be in values, and that's exactly what we have. That is great. So now the next step we need to do is like, select what do we want to use as, what do we want to have as a feature matrix. So what do we want to get to our model? And also we need to select also like what should be our labels. Well, what are we trying to, what do we want to predict? So just to also, before diving into that, also check the spot the train data info. You should make sure that everything you have here, like the most one we're going to use are either integers or floats. This one over here, the loan ID, in our case, it doesn't seem to be like it's not that actually important in making predictions. So this is basically like the person ID number that was assigned to each person. And since those values are unique, then basically we shouldn't get that into our model. So now what we need to do now is to split our data into train and test sets. So basically our feature matrix is going to be train data, and we need all the rows, and what we need as our feature, we actually print it out instead of going all the way up. So what we need as a feature is basically the gender, married, dependents, all the way to the property area. And what we're trying to predict is the status. So basically we need everything starting from 1, our gender, all the way to our property area. So if you remember indexing, what we went in the second week, check the values. It's like not working. Everything there. Key. Okay. Index location. We're going to use indexes. Yeah, perfect. And for our targets, we want to use train data, block, all the rows, and the last column values. We want to get them into one of the NumPy. And that, and voila. I'm just going to comment this out. Okay. So another thing is that it's also that I thought is very important to let you guys know is something called feature scaling. And this is very, very important because most of these like learning algorithms, like logistic regression, the way that the optimizer that it uses, gradient descent, on how to find the minimum, so I could show you like a very good. I have this right prepared for you. It's a very good image. Just a moment. So something happened to my computer. Why did it freeze? Why? Okay, I'll give it to you now. Perfect. Okay. Negative thing that doesn't happen. I'll just wait for this. Okay, perfect. Just wait while it loads. Okay. So basically, about feature scaling. So if our features are not normally distributed, so if they can't actually be integrated in any distribution like form, either like a Gaussian distribution or an exponential, any type of it, if our data doesn't fit those kind of distribution, then it's very difficult for these optimization algorithms to actually find the minimum. So basically, if we have like a feature like there's like this that is not scaled properly, you could see that over time as the optimizer is trying to find the global minimum, it's going to go through like a lot of iterations in each time, a lot of epochs of front and back, doing the propagation and backward, so upgrading like the weights and the biases. And over here, if we have like our feature matrix that is actually scaled, if it fits like any distribution, for example, like the normal distribution, then when for these linear algorithms to find the minimum, it will be much faster and much easier. While over here, if they're not scaled, it could take a very, very long time before you find the proper weights and biases to actually use. And we could also actually check out these values. So basically, I'm going to show you how it looks like before we apply feature scaling. So basically, our mean in our case, this is just a print format. So you just put the F statement, and close up with string format, the mean, and what we want to pass is like x dot mean. The mean over here is like 683, and the standard deviation is that's too much. So 2,569. So in our case, what we want to do is like we want to make sure we actually fit our data in a given distribution. So in our case, we'll be using the Gaussian distribution. So scikit-learn provides something for us. So from sklearn pre-processing, yeah, we want to import standard scalar. And so let's say standard scalar equals standard scalar dot let's differentiate the model. Then standard scalar dot fit and transform our x value. So replace our previous one with this new one. And now once we check the mean after scaling and the standard deviation, let's watch carefully. You can see now our mean is like very, very much close to like 0, and our standard deviation is actually 1. So it definitely now our data fits well in normal distribution. So the next thing we need to do now is to basically like split our data into like training and test sets. So basically from sklearn dot model selection, we want to import train test split with the xtrain, with the xtest, y train, and y test, train test split. Call it, pass in the feature matrix and the target. And also very important is to check out what exactly we have. So we have our training feature size is empty.shape, xtrain, its training label size, xtest, my training and Y test. So this is our I don't know actually our testing sites, our training label sites, and our testing label sites. And it looks like we have done a good job at splitting it properly. So now it goes to the job with building these models. So building the model part. So we also have a really good image. I'll just show you. So basically, just any questions?
Regarding scaling the data,
Yeah.
would you recommend standardization or normalization? Which one is better?
Anyone. You could use anyone. As long as you know you're actually taking care of your data. So as long as you're actually reducing like the mean. So basically, your mean value is like 0, and your standard deviation is actually 1. So that's like the most important thing. Or I
Okay.
could also say, in your way, you could test them out and see which one works best for you.
Okay.
That's what the whole. That's like the advice I'll give you.
All right.
So from last week, we actually saw about linear regression. And so basically, logistic regression is not much like different. It's pretty much like an idea that was built behind like linear regression. So the idea is that, for example, we have like since logistic regression, the only difference is that logistic regression, what we're trying to do is like we have like our R square. So basically, we want to reduce the sum of squared errors. So I actually like get my pad out. Just a moment to load my ad and reshare my screen. Um, so now I'm gonna print my entire screen. Screen 2. Okay. Forward. Okay. So how do I move this over there? Ah, perfect. Okay, nice. So the idea is like, for example, in the previous example, we saw like, for example, let's say we've got like, say the horsepower of a car. And I'll just name the text that we're writing in. Horsepower of the car is X, and what we're trying to predict is like, the price of the car. And we've got like, a line, and we've got our data points over here. So in linear regression, basically, the idea is to like fit a line to make sure that when you sum like the error distance between this data point and this line, use a different code for that. Say red. And do this over there to make sure that the distance between your data point and this line that was drawn, to make sure you have like the smallest amount of error. And so in logistic regression, we're not using the RE square. Basically, what we mostly focus in is on the likelihood. So, for example, let's say we've got like so let's say we've got like something that looks like this. So let's say you could think of an example. We could predict whether a person was guaranteed a loan or not. And so was a loan given to the person? So loan given to the person, either yes or no. And as a feature we could use like let's say based on use actually. We could say, in our case, the perfect one will be the education. Let's say the education. So I hope you can see my screen. Let's do the education. And we've got like some kind of people, some people that are graduates over here. And we've got some people that are not graduates over here. So over here, so basically we have like an S function. So it's pretty much called like a sigmoid function. Basically what we're gonna do is like pass our linear function, y equals mx plus b, pass it into like an activation function, which is like a sigmoid function. So an activation function of y. So basically our values, the output of our values are either 0 or 1, and the sigmoid function looks like 1 plus e to the power z. This could be, this is actually this function over here. So x plus b over here. Okay. And so basically, so that, for example, if we have like, if a person falls under this category here, so then we could say, we could just put it up here and we could say that, okay, the person was given a loan. And if we have like a data point over here, then the person wasn't given a loan. So basically values that are greater than or equals to 0.5, basically that person was given a loan, so the output we could label it as 1, and values definitely less than 0.5 would be 0. So the idea behind this is like, for example, let's say you have like, let's plot something on the 1D. So you have like data points over here. So you have, make this few. I have like a lot of data points over here. And we have like a few of them over here. And so let's say we've got like, you know, like a function, Gaussian function, and we plot it over time. So it started from over here, and we go over here, and once you keep shifting it, it starts like, you know, to decrease, you know, over time, starts to increase again. Another one again, starts to increase. Then another one again, increases again. Once you keep moving again, then it starts to decrease over here. It starts to decrease over time. So basically what we want is like, you know, we want the location that maximizes the likelihood. So in our case, it's this location over here. That's why the way how it works is to go to the previous page. So basically the idea is like, it starts like, for example, with something like this, and it starts to like, you know, shift it over time until we hit like a spot like this. So in our case, until we hit this spot over here. And the next algorithm that we, okay, so basically let's code a bit, then I'll talk about the next algorithm. Let me share my screen again. Tab, workshop. Okay, just to confirm, you can see my screen.
I cannot, but now I can.
The browser? Okay, perfect. Good to know. So now we need to like import our logistic regression model. So from sklearn.linear model, logistic regression, and inside we need to call classifier logistic regression. So instantiating the model. Our classifier fit our X train and our Y train over here. So this is where the training process goes on. Classify it. And once that is done, then we can check the accuracy of our model. So basically using sklearn import metrics, sklearn import metrics. And we want to use like accuracy score. So we can actually do something like this. Import. Okay. And to check the accuracy, we could do like metrics dot accuracy score. So our true, oh yeah, before we actually make predictions, we actually need to, before we need to check out accuracy, we need to make predictions. So our logistic regression predictions, our classifier dot predict, and give it like a whole new sample it hasn't seen before. And run this, put like values, ones and zeros. To check the accuracy now, so we need to pass in true and the predicted. So what are our true, the y-test? What's the predicted, our prediction? You see like 0.7, when you multiply it by 100, we get it in percentage. Also round it, 20.round. Let's say 3 decimal places. So you've got like a 7.273% accuracy. And you could also, of course, put in the print statements. First time, sign. Yeah, that looks normal. And next, we could also like, another good metrics like use a confusion matrix. So we can sklearn dot we need to import the confusion matrix. So we have like our matrix over here, confusion matrix takes in the true, so that's y-test, and our predict is LR logistic regression predictions. And then out, map. Here you get that. And to actually beautify it, perhaps you use from Seaborn. We've got like heat maps, which is the translated to data, annotates, of course, CMap. Read this. We've got format, small squares, yeah. You don't have like a rectangle shape. Perfect. And also, of course, CBAR, turn that off. And also, it's all good thing to put some labels. So we've got like the true label on our x-axis, and on our y-axis, our predicted label. And over here, so basically, you can see that our true labels were like 21, and what our model predicted, like definitely those 21 values, those 21 people were not accepted. And there's like a bit of a misclassification over here, whereby one person there's like a misclassification over with one person over here. And if you see like with the another one, whereby another person, so basically the true x, when the true labels are 0, that person was not issued a label a loan. And over here it says that okay, a person was issued a loan, so that's like a bit of an error from the model. And over here, 1 means like the person was issued a loan. So, and what our model predicted, like 98 people were issued a loan, and it says like also that 34 people were actually also like were not issued a loan. So that's also like an error over there. So that's also one thing to know. And our next algorithm is actually the random forest classifier. And also I have like a very good example over here. I can share it with you guys. So if you remember from the decision trees that I explained in the previous tutorial, what we have is like, we have different decision trees over here. So actually in the previous part, I talked about decision tree reversers. So I'm going to show you like how classification is. So just turn on my board. So let's say in our case, let's say we have like data that looks like this. So we've got like 11001 over here. We've got something like 100 over here. We've got something like 111 over here, and we have like xi1 over here, and in our y-axis we have like xi2. And now we could start by defining, like, let's say, what our model decided to come up. Our model decided to come up with a split. Let's say, like with a split over here, and also another split over here. And the decision tree would start like by saying like with this true if xi1 is greater than, and let's say we have like a new test sample. Let's say something that falls under here. I want to see, okay, which class does that belong to? So you could say like if xi1, we start by asking questions. Is xi1, if it's greater than, let's say this is 1, and okay, this is like 1 over here. So if it's greater than 1, so is it greater than 1? Yes or no? So it's exactly what we came up with. If it's not greater than 1, then we have things like over here. So we have like 0 no's, and we have 3 ones over here. And we also have another one, xi2. If it's greater than 1, and that's like this top one over here, then we have 2 zeros and 1, 2, 3, 3 ones. And if it's not, then we have like 2 zeros and 1 ones. So now with this, our new test sample over here, we have x. And we start by asking the question, is xi1, is it greater than 1? So of course, yes, it's definitely greater than 1. So we move, this is like y, yes, this is no, and this is yes. And also we have x again. So basically we know it's in this part. We ask another question again, is xi2, is it greater than 1, or is it less than greater than 1, or is it less than 1? If it's greater than 1, then we have like greater than 1. Then we say this is actually, what's the majority? It's 3 over here. So this our x point is now like, it's now going to be 1 instead of 3. But if it wasn't, then it's going to be like, let's say if we have like a new one, let's say over here, if it wasn't, so majority of them are zeros. So basically this x over here is going to be with as 0. And for that's like a decision tree classifier. And for a random forest, it's basically just like having like your data, and you have like decision like a big random forest, and we have like the data that you have like random forest. Sorry, it's a random forest model. We've got like, let's say we've got our data. So basically in our case it was 614 samples, and we split them. So EI should be less than our data. So we give like a portion of our data to this decision tree. So let's say decision tree 1 and decision tree 2, decision tree 3, and you could go on all the way to like decision tree n. And for our output, so let's say this decision tree over here, it outputs like 1, this one gives like 0, and this one gives like 1, and the other ones are given like 1, and this last one over here also gave us 1. So what we want to do is like a majority vote. So basically, majority of them are basically all the ones. So basically, our final output is going to be a 1, a 1. And so if you might ask like some questions like why is like the random forest works much better than the decision tree. So basically in a decision tree, what we normally have is like during like the training time we have like a low bias, so it fits very well during our like the training time, and over in the testing time it has like high variance, so it does perform poorly during the testing time. And using a random forest, like having like so many decision tree classifiers, we actually what we want to achieve is basically this high variance now comes like low variance, so it performs very well during the test time. So, and that's it, and now I'm going to switch back to programming. So show my tab and just confirm once you can see the screen.
Yep.
Okay. Should I round up or
Sorry.
should I round up the tutorial?
Question up to you. Do you want to continue with the tutorial? Should you round up? What's your thoughts, Krishna?
I'm fine continuing. So basically, just the last part. Oh, basically, I could just like
Since you're
Yep.
Yeah, since it's the last part, you can go ahead.
Cool. Yep.
So basically, just like import the random classifier and put like a classifier over there to instantiate the model. RF classifier dot fit. So this is the training time. Train, and we have like wide train. We've got RF predictions. So we want to make predictions. So we have like random forest classifier dot predict. Next test. And once it's done, we can check the accuracy of the model. So I'm just gonna basically copy all of this part over here and reuse it. So we've got what we need to change is, so just regression prediction. We have like and run this, change this part. And over here you can see the accuracy of the model is like 76.623. And if you compare it with like what the logistic regression gave, in our case over here, it gives us 77.273. So now if you compare these two models, so we have like 76. So this is from regression, and from random forest, we have basically this value over here. And also, of course, you could read the confusion matrix to see what went wrong. And you could continue like either with like applying other different algorithms, or you could also do more on the feature, extracting like other features, from the data that was given to you. So an advice to give on to you guys on if you want to progress, like continue to progress. Let's say you get a project and you want to start working on it. I would recommend, like if you don't know anything about it, just read about it, get some research papers, see what other scientists have applied, and it saves you time from like going through a lot of experiments and just to get an idea of what techniques they've used, apply them, try different techniques. So in our case, we've worked with logistic regression and random forest. So I would advise you to try other algorithms and test them to see which one works well, which one works best for you. And because different algorithms for different certain cases, every algorithm works better than the other, for depends on the case. And also, because this field of data science is quite hectic, it's like a lot of fields. My advice is just stay focused, stay concentrated. Every day, just learn something new. It doesn't have to be something big. Just don't stop learning and keep going. Of course, you're gonna have a lot of challenges, but it's during that time that's when actual growth comes. And usually when you're getting some kind of voices oh my goodness, you're not doing it right, well, you don't know enough math, you don't know enough mathematics, you don't have enough programming skills or something, just ask yourself this question: okay, who told you that? And once you figure that it's all over up in your head, oh yeah, just forget about it, because it's just some mind games that your brains are playing with you. And also, of course, I also started out I'm also starting out my data science blog, so feel free to check it out. It's called neurospike.com. So feel free to check it out and support the channel and the website. And good luck on your career. And I wish you guys all the best. Thank you.
Thank you, David. Have a good day, everyone.